Today we are going to enter into the new segment of the circular motion, that is the dynamics of the circular motion. Okay, so the dynamics of the circular motion can also be broken into two parts. One is what? The horizontal circular motion and the dynamics of the vertical circular motion. So right now guys, we are just going to focus on what? The dynamics of horizontal circular motion. Okay, so guys, let's see some let me set some basic premises on that. Okay, so if you see guys, when we were discussing the horizontal circular motion, basically guys, I am showing you a top view of what? A particle which is doing the circular motion on this circular path. Let's say this radius is r. We have seen that guys, this particle, if it is performing this particle guys, if this particle is performing the circular motion, it should have a centripetal acceleration towards this. I Even if it is have like either if it is, let's say, moving with the uniform circular motion, then also it will have what? A centripetal acceleration in this side. And if let's say it is moving with a non-uniform acceleration, means it has some tangential acceleration and its speed is changing, in that case also we have seen that at every instant it will need some centripetal acceleration. It means what guys? It means that if it is needing a centripetal acceleration towards the center, that is for sure, it means it should have some net force acting towards the center. Then only the particle can perform what? The circular motion. Otherwise it cannot perform the circular motion. It means guys what? Here the very basic thing that we can write down is that the particle the particle performing circular motion, in bracket I can write uniform or non-uniform, it must need a force that should act. It need a force or a component of net force that should act that should act that should act towards the center towards the center towards the center. Then only particle can perform the circular motion. This is the simple idea of what guys? The dynamics of what? Circular motion. Okay, the dynamics of what? The circular motion. And here I can say that if you see, we have seen that there is a acceleration that was coming towards the center guys, and that acceleration a centripetal was either v square by r, or we have seen that was what? Omega square r, or that was omega into v in the towards center guys, towards center. Okay, towards center we had seen this thing. So guys, what we can say, that you need a force. Okay, if it is a, try to understand here, this is something that I'm going to talk very crucial, is f net towards center will be equal to what guys? Is equal to m into ac if body is moving, if body is doing uniform circular motion. What does it mean, guys? It means that if you see, we know that, guys, if the particle is doing circular motion, if particle is doing what, circular motion, and if it is a uniform circular motion, if it is a uniform circular motion, guys, that it means that it means that, guys, what, let me change the color, is it means that in the tangential direction at will be what, 0. So guys, if at is equal to 0, it implies that ft should be also what, 0. It means at this time, guys, on this particle only the f centripetal should act. Why? Because there are only two components that we can write. If I break the force on this body, because body is moving in a horizontal direction, guys, it should not have the force in the vertical direction, because it is moving in the horizontal direction. So net force in the y direction should be what, 0. So if you talk about, guys, what, in the direction, in the plane, if you talk about in the plane, it can, if I break the forces in the this directions, I can say, guys, that in, if this side the force is what, 0, then only in this direction, guys, it should have the force. Okay, in this direction only it should have the force. And guys, when here you go, the a tangential will be what, here, 0. So only the force should be in this direction. So if you see, guys, only you will have a net force towards the center if you are performing what, uniform circular motion. So in that case, guys, the net force will be what, directly we can say that is what, f net, and that is f net towards the center, and that is equal to what, guys, mac. So here, guys, the f centripetal will be only what, your net force, okay, which is towards the center only, guys, of course. And that will be what, guys, m v square by r, or m omega square r, or m omega v, whatever you want to write down. Okay, so all these formulas are valid, guys, if you are performing what, the uniform circular motion. Okay, so guys, now if suppose if you are performing what, a non-uniform circular motion, if you are performing, guys, what, a non-uniform circular motion, that also let me clear it. Okay, so if you see, if the particle is performing what, a non-uniform circular motion, what does it mean of, guys, what, non-uniform circular motion? It means that it should have some a tangential, it means, guys, what, it means, it is very very important to understand that the particle will be having some a tangential along with the what, a centripetal. So it means it should have some f tangential acting on it. Okay, means there would be some tangential force. And of course, guys, if because it is moving on the circular path, it will be having some f centripetal towards the center. So guys, in this case, the net force will be what, it will not be towards the center, it will be what, between the tangent and between the normal. In between them there would be, guys, some resultant we will see. Okay, between them we are going to see the resultant, guys. Okay, between them we are going to see the resultant. So we can say, guys, in this case, the force should be acting in this direction. Okay, if the force should be acting, the f net will be what, guys, in this direction. That you should keep in mind. But here also, guys, if you see, the fc or f centripetal, okay, f centripetal will be what, guys, at that moment, whatever the centripetal acceleration you have, that is v square by r at that instant. So mv square by r, or m omega square r. Okay, so that will be what, guys, your centripetal force that you might need at that point of time. But along with that, your particle will be also having some external force that will be acting in the direction of the tangent of the circular path towards the tangent. Okay, guys, so these two forces will be acting on the body. So the net force would be what, guys, not towards the center, it will be what, somewhere in this direction, as that I have shown here. Okay, in this direction. So guys, this is the very basic thing that I have told you about the what, the dynamics of the circular motion. Now, guys, one more thing I want to discuss here is the centripetal condition. Okay, the centripetal condition that actually Newton has talked about in his famous book Principia of Mathematica. Okay, so centripetal condition. Actually, there is a brief history that I can tell you about here, that how this whole circular motion idea has been evolved by the Newton in himself. Okay, the thing is, when he came to the idea of what the gravitation, he told that between the two bodies there is a attraction force is there. Okay, and this attraction force is what attracting one body to another body, as we know. So the people have started asking that why the moon, let's say this is moon and this is what guys earth. Okay, so why the moon is not coming towards what earth, why it is doing the circular motion. Okay, this was a very common doubt that anybody who is a bit a good observer, he can ask this thing to you. Okay, so the people started asking this question to the Newton that why this is so, like why the moon is not falling, why it is doing the circular motion, how would you explain that? So actually, to explain this whole thing guys, okay, he performed certain experiments, and there are lot of things that you can google it, or you can use chat gpt to get a little bit more detail. But here guys, what I want to show you is the real work that he had done at that point of time. Without using calculus, he had used some basic geometry and some basic kinematics, and he had came to the idea of what is centripetal condition, and he had said that why the moon is not falling, why he is performing the circular motion or nearly the circular motion. Okay, actually he follows the little bit elliptical orbit, but nearly it follows a circular path. Why it is following the elliptical orbit and all those things we will see in the gravitation. Okay, so for right now guys, I'm just going to show you, I am going to showcase, I am just trying my best to show you what the craft, the work that he had done at that point of time to show why the moon is performing the circular motion, why it is not falling down. Okay, so so let me try that guys. Okay, so if you see, actually guys, the thing is, uh, see guys, let's say this is your earth. Okay, basically it would be rightly to say is what that it is our earth. Okay, so guys, this is our earth. Okay, and let's say guys, this is the moon we are having. Okay, 1 minute guys, I think I have wrongly made it, just let me place it here. Okay, so guys, this is your, this is our moon. Okay, this is our moon. And let's say guys, this distance is what r. Okay, this distance is what guys r. Okay, and we know that by the uh, lot of observations done by already before the Newton only, by the Galileo, by the Tycho Brahe. Okay, all those scientists guys, that the moon moves in a what circular path. Okay, so now guys, we want to see that how it is doing this motion. Okay, so see the how he beautifully came to this geometry. Okay, so if you see guys here, as the moon, let's say guys, moon reaches to this point. Okay, moon reaches to this point, and if you see guys here, the moon has gone down certain value. Okay, here if you see guys, this there is a slight fall we can show. Okay, let me show you this thing with some color. Okay, some bright color, I guess that would work guys. So here guys, this is what uh, delta y I am showing. Okay, delta y that he had used, this delta y is the vertical displacement that has came guys. Okay, the vertical displacement that has came, Now if you see guys, uh, for a very small theta, for a very small theta, we can assume that this force, this is acting towards the center. Okay, the force which is acting towards the center, okay, this force that is acting towards the center, which has what, the brought this delta y displacement, okay, we can say, because the body has no velocity in the towards the center, okay, but still it has gone down with this delta y. So what we can say guys, for this delta theta, if I show you, what I can say, that there is some force acting towards the downward direction guys, okay. This force is nothing but what, your gravitational force, okay, towards the center, towards the center guys, and that is what, g m1 m2 by r square, okay, g m1 m2 by r square we know, okay. So guys, this is the force which is acting towards the center. So let me write like this way, okay. Guys, gm small m divided by r square, okay, r square. Now guys, if you see, what we can say, the acceleration towards the center that the particle was having is how much guys, that is the force towards the center divided by the mass of the body, means mass of the moon. So this will be what guys, this will be gm divided by r square. I hope you're getting my point. So due to this force guys, due to this acceleration, the body had this delta y displacement towards the center, okay. We can say that this displacement that has came is because what guys, because of this acceleration which is acting towards the center, okay. So this delta y which has come is because of what, this ac only guys, okay, which is acting towards the center, okay, or we can call it also ay if you want, okay. So guys, if you see, the uy is equal to what, 0. We know that guys, that the particle when it is moving, when the particle when it is moving, it is moving tangentially, so it is not having any vertical downward velocity towards the center. So guys, it means uy we can take it what, 0. So guys, I have taken uy as what, 0, okay. After that guys, if you see, uh, if we show it guys, so if you see, 1 minute, what we can write is, we can write delta y is equal to uy into delta t plus half ay delta t ka square guys, okay. This we can write. So because guys, the delta, sorry, the uy is what, 0, okay, uy is what, 0. So we can make this equal to what guys, 0. So delta y is equal to what, half ay delta t square, okay. Half ay delta t square. I hope this is okay. Now guys, try to understand here. The thing is that this delta y we can replace with something, okay. What, if you see, this delta y is equal to what guys, half a delta t square. So now if you see guys, this body has gone up to what, up to some distance here. If you see, this is the thing, okay. 1 minute guys, okay. So this is what guys, you can say, your uh, delta s displacement, okay. The display, sorry, the displacement you can say, okay, or the distance that it has traveled, okay. So if you see guys, the thing is, the delta s, the delta s is equal to what guys, r into delta theta. Delta s is equal to what guys, r into delta theta. Now guys, here what I'm going to do, I'm going to trying to replace this delta s by what, by this r delta theta, like this delta t guys, I want to replace, okay. So if you see guys here, what I'm going to do, we know that this just a minute guys. Okay, just a minute. So this delta y we have, okay, and delta y we have to replace guys. Okay, so we don't need to go in this direction, I guess. Okay, so leave this thing, let me go in other way. Okay, so guys, this we got. Okay, now if you think guys, here the this is what guys, this is r only, and this is also what guys, r only. So if you see this part guys, this part, the delta y, we can say if this is delta theta, if this is guys delta theta. Okay, so here if you see guys, this is a right angle triangle. So if this is r, this will be what guys, this will be r cos theta. So let me write down the guys this. So this will be also what guys, r, and this will be r cos theta. Okay, r cos theta guys. So what we can say guys, that delta y is nothing but what, it is equal to r minus r cos theta. Okay, delta y is equal to what guys, r minus r cos theta. So let me put that thing guys geometrically. So delta y I am replacing with the what guys, r 1 minus cos theta, and that is equal to what guys, half ay, okay, into what, delta t square. Okay, half ay delta t square. Now guys, if you see the let me put this theta guys. Okay, here, mm, just a minute guys. Okay, this is 1 minute, this is guys cos delta theta. Okay, cos delta theta, and here also guys, let me replace this. So this is actually guys, it will become delta theta. Okay, so now guys, this delta theta is what, very very small. Okay, so for a very small journey guys, we are analyzing this part and we are making it so. So guys, if you see r 1 minus cos delta theta guys, so I am just going to use some approximation. So guys, cos delta theta I am converting into first sine form. Okay, so sine form guys, if I want to convert, what I can write, I can write this as cos delta theta can be written as 1 minus 2 sine square delta theta by 2. I hope you know this thing guys. Okay, it's a very simple approximation that I have done, is equal to half ay delta t square. Okay, so guys, now if you see the r, and guys, this will become what, 2 sine square delta theta by 2 is equal to half ay delta t square. Okay, so guys, if you see here r, it will become what, 2 in bracket, for guys, you know that here, let me write down, if delta theta is very small, then sine delta theta can be approximated as what is delta theta. So guys, here what I can do, I can write this as delta theta by 2 ka whole square. Okay, and is equal to half ay delta t square. Okay, so guys, it will become half 2 delta theta square divided by 4 is equal to half ay delta t square. So guys, this will become 2 and this 2 to cancel. So what we get, just let me add guys few pages. Okay, so guys, if you see here, that what we got are delta theta square is equal to ay delta t square. Okay, so guys, here if you see, the ay is equal to delta theta by delta t square into r. Ay is guys nothing but what, the acceleration towards the center, and delta theta by delta t guys can be approximated as what, omega. So it is omega square r. Okay, so guys, what we can say, that if your force is able to provide this much, if your force is able to provide guys what, this much, let's say, if your force is this much that is acting on a body guys, try to understand the centripetal condition. Now guys, I am going to explain this, so try to understand. So guys, if you see, if your body is like, let's say guys, this, okay, this is your body, okay, and guys there is one particle here, okay, there is a pull which is coming towards the center guys on this body. Let's say this force is F. So guys, of course this force is producing a certain acceleration towards the center, that you are getting my point, okay. If this acceleration which is guys pulling this body towards the center, if you want that this body should do the circular motion without falling towards the body, what it should do, it should have a certain velocity or a certain angular velocity. Better to say in terms of velocity guys, okay. So what we can say here, if let's say is this is equal to what, v square by r. So guys, if you try to understand, if your velocity is not like fulfilling this value equal to what, this value, then guys what will happen, your body will not be able to sustain this circular path, it will fall down, okay, it will go like this, okay, it will fall down, it will not be able to follow this circular path at all, okay, it will not be able to follow this circular path at all, it will fall down guys. So the centripetal condition guys here, what did the mean of centripetal condition? Centripetal condition says guys that your velocity, okay, your velocity should be, okay, your velocity should be equal to, okay, equal to what, the under root of r into, sorry, a into r, okay, like this way, okay. This is the thing guys, okay, if your velocity is balancing this thing, then only what you can do, you can handle a particular orbit, okay. If your velocity is not able to is not that much enough that it can handle this condition guys, then what will happen, it will fall down, or it will go into a lower orbit and it will start circling in that orbit, okay, that is going to be the case. But it can't sustain here guys, means it's a very simple example guys through which I can prove this thing, this thing to you. If you see, when guys we are throwing a particle from the ground guys, it do the projectile motion and it fall on the ground, okay, it does not go and what, do the circular motion about the earth, okay, it is not. Why? Because if you see, the force that is acting on this particle towards the center of the earth, if you, let's say this is the center, okay, if we precisely, let's say we take like this way, so guys the force that is acting on the particle or the body is more compared to guys what, the this velocity which is needed is not available, okay. So velocity which is needed to maintain the centripetal condition is not available guys, and that's why what happens, our body follows the projectile motion and it like the parabolic path, and it falls down the ground, okay. But guys, if we give the sufficient velocity from the ground also, it can perform what guys, circular motion from the ground itself, okay, if we give a enough velocity. That's all that I want to communicate here, okay. I hope you're getting my point, what I'm trying to talk here, okay. So this is the guys, the actual or original derivation that Newton has done at that point of time to give the idea of what circular motion, that how the circular motion has come, okay, how the moon is what moving around the around the earth, why it is not falling down. So I have tried my way to explain you this thing, okay, and I hope you understood that how he had explained with the simple geometry and the kinematics, okay. So if you want to do a little bit more research and the study guys, you can go and you can check this thing on some certain references, like basically better to go on the chat gpt or something, you can get some more clarity or the more work that he had done regarding this thing, okay. So guys, I hope you understood the idea of what the dynamics of circular motion. Now let me take some few basic examples so that this idea becomes more concrete in your mind, okay. So guys, let's start with a very simple problem. So problem number one guys, okay. So problem number one. So guys, if you see, problem number 1. Okay, the problem is like this way guys, that there is a horizontal table. Okay, there is a horizontal table. Okay, this is a top view guys. Okay, this is a top view, so don't get confused that sir it is not a horizontal table guys, it is a top view. Okay guys, there is a spring which has been clamped from one side guys, and this the other end is what guys, attached to a block mass m. Okay, block mass m, and the natural length of the spring is what guys, is L naught, and the spring constant is what guys, K unit. Okay, Newton meter you can take. Okay, now guys, it has been said that the spring has been given, the spring has been given 1 minute guys. Okay, the spring has been given a angular velocity omega in the plane. Okay, yeah, the particle the spring is now rotating, you can say, in the plane only guys, with the angular velocity what, omega. Now the question is, what would be the radius in which the block will be moving. Okay, and what would be the force that would be acting in the spring. Okay, what would be the force acting in the spring, and what would be the radius of the circle in which it will be moving. Okay, this kind of a question they might ask. It's a very simple question guys, if you want to try it you can try it, otherwise let me show you the solution guys. Okay, because if you see here, actually what will happen, as you start rotating guys, it will not stay here. Okay, because you know that if it will stay here guys and it will rotate here, it will need a force toward the center, and that can't happen guys. Okay, it can't happen because the spring is in it what, in its natural length, so it is not possible. It means guys what, it will get either compressed or it will get elongated. Okay, now guys, if you see, if you try to rotate the body, if you try to rotate the body, okay, like this way, in the vertical direction. Okay, let's say guys, if you start rotating like this. Okay, if you start giving the velocity like this, so guys, if you see, in that case, this body will try to go in like this way guys, so it will elongate the spring, is this or not, because it is trying to go like this way, so spring is fixed this side, so it will guys what, it will initially try to elongate the spring. So of course guys, it is not going to compress, it is actually what, it is going to elongate, and then it is going to move on a circular path. I hope you're getting my point what I'm going to say. Okay, so it means that there is going to be elongation in the spring, and there would be a certain elongation, and after that the body will achieve an equilibrium state of motion, and in that case it will be moving on a circular path. Okay, so guys, let's say if I show you the thing, that let's say guys, the particle is here, and it is guys what, it is doing this circular motion. Okay, so guys, this length will be what guys, now L naught plus x, means now guys, it will not be its natural length, it will be what, a certain elongation that it will be having. Okay, and then guys, it will be moving on the circular path. So guys, we know that because it is moving with the uniform uh, velocity guys. Okay, uniform angular velocity, it means it will have a uniform guys what, a magnitude of what, centripetal force towards the center. Okay, because without that only it can't move. Okay, so it means it needs a centripetal force towards the center, and because omega is constant guys, we can say that the body is also going to have a same force towards the center, that is what, your centripetal force. So guys, this fc, or the centripetal force, should be equal to what guys, m omega square r. Okay, where m is what, mass of the body, and omega is what, the angular velocity, and r is the what guys, the distance from the center. So guys, if you see, f is nothing but what, the spring force only guys, f is nothing but what, the spring force only guys. So what we can say, that it should be equal to what, k into x, because x is the what is elongation in the spring. So k into x is equal to m omega square, and r is guys what, the distance from the center, that is what, l naught plus x. So guys, from here if you see, we can say that k into x is equal to m omega square l naught plus m omega square x. So guys, x will be how much, k minus m omega square is equal to m omega square l naught. So x will be how much guys, x will be simply m omega square l naught divided by k minus m omega square guys. So if we got guys x, means we can get the radius and we can get the force. Force will be what guys, k into x. Okay, so if you want to report the force in the spring, that is what guys, k m omega square l naught divided by k minus m omega square. Okay, so that will be what guys, your spring force, and radius guys will be what, L naught plus x. Okay, so guys, that is a very simple problem that I had to show you the application of what guys, we can say, of this dynamics problem. Okay, like the concept of the dynamics. Okay, now guys, let's take one more simple problem only, okay, to understand the idea. So guys, problem number 2, problem number 2, problem number 2. So guys, there is a idea of conical pendulum guys. Okay, conical pendulum. So actually a conical pendulum is nothing but guys, what, you have a rod, sorry, a string like this, okay, and you have a block like this guys. You give a certain angular velocity here, and what happens guys, the thing is, it will, one minute guys. Okay, okay, it will actually start moving, it will actually guys start moving like this. I'll show you. It will start moving like guys this. Okay, so this is the motion guys that you will see when it will be moving. Okay, so guys, this is known as what guys, a conical pendulum. uh, okay, and now guys, let's say this mass is what, m, the length is what guys, l. The question is that if it is guys rotating, okay, if it is rotating like this way, and this radius is given to you what guys, r. Okay, this radius is given to you guys, what, r, in which it is rotating. They are asking, find out, find out the, find out tension in the string, and and angular velocity, angular velocity of the particle. Okay, very simple question guys. Okay, so we have to just use the Newton's second law and we can deal with this problem very easily. So if you want to try, you can try guys, otherwise I'm going to do the solution. Okay, guys, see solution of this part. So guys, if you see, let's say this angle is what, I am taking theta. Okay, from my side I'm assuming this angle is what guys, theta. So guys, we know that if the body is moving in a circular path, circular path like this guys, in a horizontal path, it means the vertical forces should be what guys, balanced, because it is not moving in the vertical direction, it is only moving in the what guys, horizontal direction. This is, I hope, very very clear to you. So guys, if you see now, on this body there are three forces are acting guys. One is, only two forces, sorry. Okay, one is what guys, this tension, and the other one force is what guys, mg. Okay, so guys, we can say if this theta is there and this is what guys, theta, so we can say the t cos theta is equal to what guys, mg. This is the vertical direction equilibrium guys that we have to maintain. And guys, if you see the t sine theta, okay, this is guys what, t cos theta, and this is your tension t, and this will be what guys, t sine theta. Okay, so guys, t sine theta is only going to be what guys, your centripetal force, which is going to help you to move the particle in a circular path. So guys, t sine theta should be equal to what, m omega square r. I hope you're getting my point. So guys, what we can say, that the tension is nothing but what, mg by cos theta. And cos theta guys, we can calculate very easily. If you see, the angle theta is this. If this is guys theta, this will be how much, this is guys what, r, this is r. So guys, we can get this value, and this value will be what guys, this value will be simply under root of what, l square minus r square. So we can say guys that here this will be what, mg upon under root of l square minus r square, and r will be what guys, come in the upside. So guys, it will be what, mgr divided by under root of l square minus r square. Okay, so guys, this is what, this is your tension. And if you talk about guys the uh, omega, so we can use guys what, t sine theta is equal to m omega square r. So guys, let me write down the things here. So t will be what guys, that is mg r divided by under root of l square minus r square. Sin theta will be what guys, r divided by under root of l square minus r square is equal to m omega square into r. R is what guys, r only the radius. So mm guys cancel. Okay, 1 r 1 r will be what guys, cancel. So omega will be what guys, that will be, you can say, it will be gr divided by l square minus r square under root. Okay, so guys, this is your what, the omega in radian per second, if the things are given in the SI units. Yeah, okay, like we can just simply say that this is omega unit. So this is what guys, the angular velocity that you will get in this case. Okay, I hope this is also very much settled to you, that how we have to get this answer. Okay, I hope guys this is very clear to you. Okay, now guys, let's move to one more problem, so that get a bit more uh, more clarity guys about these kind of problems. Okay, so let me take one more problem for you. Okay, let me take one more problem for you. So guys, this is actually from the illustrations of what, the solved examples that HCV sir has taken in the circular motion chapter. So from there guys, only I am taking this problem. The problem says like this. It's a good problem, and it is very you can say a kind of problem that you can see in all sorts of chapter. Okay, in the circular motion, in the what we can say, in the magnetism, in the electrostatics. Okay, so a lot of the places, even in the surface tension also. Okay, we use this problem in general. Okay, so it's a very general problem guys, and the approach of this question, you should learn that how you should handle if this kind of a problems come in front of you. Okay, so the question is like this guys, that there is a there is a horizontal plane guys, on which we have a metal ring. Okay, we have a metal ring. mm, yes, okay, I think, just let me move this thing a little bit, so that I can get this aligned. Okay, okay, that's a problem I guess. mm, Let me try once more guys. Okay, maybe I can get this. Okay, okay guys, okay, let's accept this only. Or 1 minute guys, let me do it out early. I think this is much more better. Okay, so here guys, this is a metal ring. Okay, and it's a thin ring. It's a thin ring, and what is given in this question, if you see, the radius of this is r. Okay, the radius is what guys, r. thickness you can ignore, okay. If it is needed in the calculation, we will see, we will take that t, okay. Guys, it has been said that uh, that this ring has been rotated about its axis with the angular velocity what, omega. So it has been asked that find out the tension in the what, tension in the ring, okay, the tension in the ring, okay. This is the question that has been asked. So guys, uh, according to my idea, like the better way to put this question is what, the increase in the tension, okay. Because see, if you are bending what we can say, metal or something, you automatically have put it some tension into the body itself, okay. So if you are having a bended body, guys, it is already have a certain tension, but because you are rotating it, now guys the tension is going to increase, okay. So why it is going to increase, the increase in tension, guys, we want to study. So let's understand that part, guys. So if you see here, guys, if I show a very small element to you, if I show you guys a very small element to you, if you guys just focus on this element, we can say this element is, guys, what, it is moving on the circular path, okay. It is moving on the circular path. Right now it is what, here, some after some time it will be here, and after some time it will be here. So if we mark it here, guys, this marker will be moving. So guys, we can say this element is also what, moving on the circular path. I hope this is very much like settling for you, okay. You can visualize this thing, okay. So now guys, if I make this elemental part in a zoomed format, okay. So guys, let me put this thing aside, okay, and let me draw this thing here only, okay. So if you see, guys, I'm taking this small element and I'm going to draw this here, okay. mm, yes, I think it will work. Guys, if you see this body, this small part has, guys, let's say the subtending angle is what, d theta. This small part is having, guys, what, subtending angle is what, d theta. And guys, this body uh, guys will have the tension is always, guys, going to be what, away from the body, we know that. So we will made it, guys, what, delta t and delta t, which is what, guys, increase in the tension, okay, increase in the tension. So because the body is only, guys, doing the what, circular motion, it is not moving here and there. So guys, like if you see, if the delta t here and delta t here is what, different, guys, so net force will come in this direction. It means what, this body is going to move from here to here, means it is not going to stay there, it is going to move, and this is going to do circular motion also. That is not possible because it is a rigid body. So guys, it is going to be stay there. So to make it stay there, guys, this force and this force should be what, same. That is also very important to understand fundamentally, okay. Now guys, if you see here, the thing is that if I show you the guys, you know that the radius and the tangent is always what, guys, perpendicular. So guys, this angle will be what, 90 degree. I hope you're getting my point. Like this way, guys, this will be also what, 90 degree. Yes, I am dropping a, like this kind of a uh, line here. I am drawing this line, guys, and I am dropping a perpendicular to this point, guys, okay. Now if you see, guys, this is also going to be what, 90 and 90, guys. This will be what, this will be d theta by 2. This will be also what, guys, d theta by 2. I hope this is settled. So guys, if this is d theta by 2, this is 90, guys, this will be what, this will be what, guys, 90 minus d theta by 2. Now guys, if you see, this is something like this, okay. If you see, guys, this is a line, okay, that I am drawing. So guys, this is 90 minus d theta by 2. Now if you see, guys, this is 90 minus d theta by 2, this is 90. So guys, this will be what, d theta by 2. I hope you're getting my point, because this is what, guys, 180 degree, okay. So guys, if this is 90 minus d theta by 2, this is 90, this will be what, guys, d theta by 2. So guys, here this angle will be what, d theta by 2. So by the symmetry guys, I can say this angle will be also what, d theta by 2. So guys, now if you see, the thing is, the if I zoom this guys, okay, what I can say, I can say that this uh, delta t guys, okay, will have one component along this, and this delta t also will have guys one component along this, and by symmetry guys, this and this will get what, cancelled out, and guys they will have one component along this, and it will also have guys what, one component along this, and these two get what guys, added, and it will be what guys, towards the center. Okay, so guys, this total net force if I draw, okay, this total force if I draw, so the delta t guys, if you see, this will be what guys, this will be delta t cos d theta by 2. So guys, this will be what, of course guys, here a lot of things are have been what, messed up, so please see it carefully. So guys, here just let me put it in a different color. So guys, this one will be what, it will be delta t sine d theta by 2. I hope you're getting my point. So guys, this will become what, uh, 2 delta t sine d theta by 2, that is guys what, acting towards center, and it will be guys what, your centripetal force. Okay, it will behave like guys what, centripetal force, to make the body to move on a what, circular motion. Okay, to make the body to move on a to perform circular motion guys, because we know that every element, every mass should have guys what, a net force toward the center if it is performing a circular motion. So guys, 2 delta t sine d theta by 2 is equal to what guys, the mass of this element guys. So let's say guys, the density is what, the density of sorry, let's say the mass is what guys, of the ring is capital M. Okay, the mass of the ring is what guys, capital M. So guys, what we can say, the mass of this element will be what, if you see guys, the density, the linear mass density will be what, lambda is equal to m divided by 2 pi r. So lambda is guys what, m divided by 2 pi r, and guys, how much is the length of this element will be what guys, that will be r d theta, element length. Okay, element length. So guys, what we can say, we can say the dm of this element will be what, it will be m divided by 2 pi r into r d theta. So r guys cancel, it will become what, m d theta divided by 2 pi. So guys, the 2 delta t sine d theta by 2 is equal to m omega square r. So m is what guys, dm omega square into r is what guys, r only. Okay, so guys, if you see here, because theta is very small guys, so I can do the approximation. So it will become what guys, d theta by 2, and dm is equal to what guys, m d theta divided by 2 pi into omega square r. So guys, d theta cancel 2, 2 to cancel guys here, let it be this 2 here. Okay, let it be guys this 2. 1 minute, let me remove this guys and put it the 2 here only. Okay, 1 minute guys, so 2 is here only. So guys, this 2 to cancel, and this delta t is remaining. So guys, the delta t is nothing but, if you see guys, this is capital M, capital M om m omega square r divided by 2 pi. Okay, m omega square r divided by what guys, 2 pi. So guys, the increase in the tension that we have found is what guys, m omega square r divided by 2 pi. Just check the calculation guys, I think that is correct only. So guys, this is one of the standard problem that we should know that how to handle. Okay,